Hello students, under the topic asymptotes, we have the next problem here. The question is, find the asymptotes for the given curve. Now for this curve, we have to find the asymptotes. As the first step, we have to check the degree of the equation. So what is the degree of the equation? The highest power is the degree of the equation. And we could see that the highest power is 3. Because for x we have x cube here, and for this term it is x square and y. So we have to add the powers of these two variables in order to get the degree of this term. So x square and here it is y power 1, so it will be together power 3, and here also x has the power 1 and y has the power 2, so together the power will be 3, and here y cube we have. So all these terms constitute power 3, and that is the highest degree of the complete equation. So therefore the highest degree of this equation is 3, and we all know that the number of asymptotes will be equal to the highest degree of the given curve. So therefore the maximum number of asymptotes for the given curve is 3. So let us first write that. So I have written that here. After finding the degree of the equation, we have to check for the coefficient of the highest degree for the x term and the y term in order to find whether parallel asymptotes exist for the given curve. So in order to find whether the parallel asymptotes exist for the given curve, first of all we have to check whether x cube term exists in this equation. That is, the coefficient for x cube exists or not. So if we check here, we have x cube term whose coefficient is 1. So therefore the x cube term exists, which implies that there is no parallel asymptote for x-axis. And for the y-axis, we have to check whether we have the existence of coefficient for y cube term. So if we check here, we have a coefficient for y cube term, which implies that there is no parallel asymptotes to y-axis. So let us write that now. So I have taken that and I have written here coefficient of x cube exists. So therefore there is no parallel asymptote to x-axis. In a similar way, coefficient of y cube exists, and so there is no parallel asymptote to y-axis. So as the next step, we have to write the equation of the asymptote. We know that the equation of the asymptote is y is equal to mx plus c. And here we have 3 asymptotes, and so we will be having 3 equations for the asymptotes. So let us write that now. And before that, because there are no parallel asymptotes to the given curve, the asymptotes for the curve is only oblique asymptote. So let us write that also. So therefore the given curve has only oblique asymptotes, and also the equation of the asymptotes are given here. So we have 3 equations of the asymptotes in which we have to find the values of m1, m2, m3, and using the values of m1, m2, m3, we have to find the corresponding values of c1, c2, c3. So let us do that now. So in order to find the value of m1, m2, m3, we have to consider all the terms with highest degrees. That is, we know that the highest degree of the given equation is 3, and we have to consider the terms with power 3. So these are the terms with degree 3. And if you see here, x square, 3xy and 2y square are terms with degree 2. That is, the power of these terms is 2. And this is a constant term. So we shall consider all the terms with degree 3 and write here. That is, we will name it as phi 3 of x comma y, because it is in terms of x comma y. So that is equal to x cube minus 5x squared y plus 8xy square minus 4y cube. So these are the terms with power 3. Now in this we have to put x is equal to 1 and y is equal to m in order to find phi 3 of m. So when we do so, phi 3 of m will be equal to, so phi 3 of m will be equal to, now in this we have to put x equal to 1. So wherever we have x, we have to replace it as 1, and wherever we have y, we have to replace it as m. So what will happen? X cube. So 1 cube is 1 minus 5 again multiplied with 1 square. So 5. Y is what? M. So it will be 5m and plus 8m square and minus 4. Y is equal to m. So m cube. So this is phi 3 of m. Now in order to find the values of m1, m2, m3, we have to equate phi 3 of m to be equal to 0. So when we put phi 3 of m to be equal to 0, we have to equate this complete term to 0. Let us write in the order of the powers. The highest power is minus 4m cube. So let me write that. So minus 4m cube plus 8m square minus 5m and then plus 1 is equal to 0. Now let us see, we have to find the roots of this equation. So how many roots will it have? The highest degree is 3, and so this will have 3 roots. First root let us find by synthetic division. In order to do that, let us just have a check whether 1 is a root of this equation or not by trial and error method, for which we shall just substitute m equal to 1 and let us check whether we are getting 0. So when we put m is equal to 1, what do we get? Here if it is m is 1, we get negative 4, and again m square, so 1 square is 1, so plus 8, and if m is 1, minus 5 plus 1. And when we simplify this, we get it to be 0. So therefore m equal to 1 is the root of this equation. So we can write that. So m equal to 1 is a root. Now in order to find the other 2 roots, we shall use synthetic division and divide this by 1 and get the quadratic equation, and from the quadratic equation let us find the other 2 roots. So in order to do synthetic division, I have taken and written the coefficients of m cube, m square, m and the constant term here. Now let us do the synthetic division. We have found that 1 is a root. So we are going to divide all these with 1. So when we do so, the first term will come as it is. So minus 4. Now multiply minus 4 with 1. It will be minus 4. So 8 minus 4 is 4. So 4 multiplied with 1, 4. Minus 5 plus 4. So it will be minus 1. So minus 1 multiplied with 1 will give us minus 1. And plus 1 minus 1 will get cancelled and this becomes 0. So because the remainder is 0, of course we can confirm that 1 is a root. Now these terms has to be written in the quadratic equation, where this will be the constant term, this will be the coefficient of x term, and this will be the coefficient of x squared term. But here we are using m, right? So this will be coefficient of m and this will be coefficient of m square. So let us put it in the form of a quadratic equation. Now this is the coefficient of m square. So we will have minus 4m square plus 4m and the constant term minus 1 is equal to 0. Now we need to factorize this quadratic equation. First of all, we will multiply by minus throughout. So this term will become plus. So 4m square. This will become minus. So minus 4m. Minus into minus will become plus 1 equal to 0. So I have completely multiplied the complete term with respect to, I have multiplied minus 1 throughout in order to have this term as positive. So after this, we have to proceed to factorize this. In order to factorize this, I am going to use Hill method. You can also use the formula method and factorize it. And in order to do the Hill method, I find a constant for m square. Coefficient for m square here. Now this coefficient has to be multiplied with this constant term. So 4 1 times is 4. So I have to factorize it in such a way that the sum of those two should give me the middle term. And I can do 2 times is 4, and because I need a negative sign here and I need a 4 here, I can have it as minus 2, so that minus 2 will give me minus 4 when added up. And product of these two, minus into minus, will become plus because I need a plus 4 here. It is minus 2 multiplied with minus 2 is plus 4. Now I can rewrite this equation 4m square, and this minus 4 can be written as minus 2m, and then minus 2m plus 1 is equal to 0. Now in these first two terms, I observe that 2m is common. So we can take 2m as common, and what will be left out here? A 2m and then minus 1. In a similar way, in these two terms, I am taking the negative 1 common, and so within the bracket we will be left out with 2m minus 1 is equal to 0. And so finally we have again this 2m minus 1 is common, so 2m minus 1 multiplied with 2m minus 1 is equal to 0. And from this we get the two values of m, but we find that both the values are same because 2m minus 1 equal to 0 will give us m is equal to 1 by 2. And also this 2m minus 1 is equal to 0, and so 2m will be equal to 1, and therefore m will be equal to 1 by 2. We observe that the other two roots are equal roots. Yes. Now having these three values of m, we have to find the corresponding values of C1, C2 and C3. So let us do that now. So therefore the value of m1 is 1, m2 is 1 by 2 and m3 is equal to 1 by 2. So these are the three values. Now first value is m1 is equal to 1. For that we have to find the corresponding C value. So let us do that now. So when m1 is equal to 1, we see that m1 equal to 1 is a distinct root. And for distinct root, the formula to find C1 will be equal to minus phi 2 of m divided by phi 3 dash of m. Now in order to substitute in this, from the given equation, we have to gather the terms with degree 3 and degree 2. Already we saw that phi 3 of m is equal to, we have already written here previously. You can see here, phi 3 of m is what? 1 minus phi m plus 8m square minus 4m cube. So let me write that here. So 1 minus phi m plus 8m square and then minus 4m cube. Now we need phi 3 dash of m in the denominator. So what is phi 3 dash of m from this? We have to differentiate this. So differentiation of 1 is 0 and differentiation of minus phi m. We know that the differentiation for m is 1 and so it will be minus 5. Plus 8 multiplied with the differentiation of m square, which is 2m. So 8 2 times will be 16 and so we will be having 16m. Minus, here we have m cube and its differentiation is 3m square. So 4 3 times is 12. So 12m square. So we have phi 3 dash of m to be equal to minus 5 plus 16m minus 12m square. Next, from the given equation, we have to find phi 2 of m, for which first we should write phi 2 of x comma y, which is all those terms with degree 2. So what are the terms with power 2? Already I showed you here. X square minus 3xy plus 2y square. All these three terms has power 2. So this is phi 2 of x comma y. So let us take this alone and write over there. So we will be having this to be equal to x squared minus 3xy plus 2y square. Now in this we need phi 2 of m, for which we have to put x equal to 1 and y is equal to m. So phi 2 of m will be equal to, now wherever you have x, replace it by 1. So 1 square. So 1 minus 3 into 1 is 1. Y has to be replaced by m. So 3m plus 2m square. So this is phi 2 of m and this is phi 3 dash of m. So we can take these two and substitute in order to find the value of C1. So therefore the value of C1 is equal to minus of, what is phi 2 of m? 1 minus 3m plus 2m square divided by phi 3 dash of m is minus 5 plus 16m minus 12m square. After writing C1 equal to this, we all know that M1 is equal to 1. So because we are finding C1, here we will be using M1 completely. So therefore C1 will be equal to minus of, instead of M we have to put 1. So when we do so, 1, if M is 1 here, it will be minus 3 plus 2 divided by minus 5 plus 16 and then minus 12. But we see that in the numerator we have 2 plus 1 is 3, 3 minus 3 is 0, and so the complete term becomes 0. Therefore the value of C1 is equal to 0. So when m is equal to 1, we obtain the value of C1 to be equal to 0. And therefore what will be the equation when we substitute y equal to mx plus c? That is, we know that one of the asymptote is m1x plus c1. And so therefore the asymptote y will be equal to m1 is 1. So when you put 1 here, it is x. And this is 0. So plus 0. So bringing this x to the left, we get y minus x equal to 0 as one of the asymptote. So this is the first asymptote that we have obtained. Now we have to find the other two asymptotes. So in order to find the other two asymptotes, we observe that the other two roots are what? Equal roots. And whenever we have the equal roots, the formula to find the value of C is given by. So this is the formula. I have explained about this formula in our previous lecture. Kindly go and learn the formula from those lectures. So this is the general formula, and in particular here, what is the degree of the equation? It is 3. So the value of n is 3, and so the formula will be this. So we will be using this formula to find the other two roots. Already we saw that phi 3 of m we already wrote, using which we have already found phi 3 dash of m. Now we need phi 3 double dash of m over here. So which will be, we have to differentiate this again. So phi 3 double dash of m is equal to, the differentiation of minus 5 is 0. It's a constant. And the differentiation of 16m. So m, when we differentiate, we get 1, and so it will be 16. And then minus the differentiation of 12m square. The differentiation for m square is 2m. So 12 multiplied with 2 is 24. So 24m is the differentiation of 12m square. And so we get 16 minus 24m. In a similar way, we have already found phi 2 of m, which is 1 minus 3m plus 2m square. Using this, we have to find phi 2 dash of m. So what is phi 2 dash of m? When we differentiate 1, it will be 0. When you differentiate minus 3m, you get minus 3. And when you differentiate 2m square, you get 4m. So this is phi 2 dash of m. And what is phi 1 of m? How to find that? We have to first of all write phi 1 of x comma y. That is, in the given curve, those terms whose degree is 1, we have to take and write here. So when we take the curve and when we see that this is of degree 3, this is of degree 2. But we don't, and this is a constant term. We don't have terms with degree 1, and so it has to be taken as 0. So now because we don't have terms with degree 1, so this will be taken as 0. And therefore phi 1 of m will also be equal to 0 in that case. Now we have to substitute phi 3 double dash of m, phi 2 dash of m and phi 1 of m in this equation and find the value of C. So let us do that now. So therefore, when we substitute phi 3 double dash of m over here, we get c square by 2 factorial multiplied with phi 3 double dash of m is 16 minus 24m. And then here plus c by 1 factorial multiplied with, what is phi 2 dash of m? It is negative 3 plus 4m. And then phi 1 of m, what is that? It is 0. So it will be equal to 0. Now we have two values of m, which is obviously 1 by 2. Both are same. So we have to substitute m is equal to 1 by 2 in this equation. So when we do so, what we will be getting? C squared by 2 factorial is 2 only. Because 2 factorial is 2 into 1, which is 2. Multiplied with 16 minus 24 multiplied with 1 by 2. So 24 divided by 2, which will be 12. Plus c by 1 factorial is 1 only. So c multiplied with minus 3 and m is 1 by 2. So 4 multiplied with 1 by 2. So when we divide 4 by 2, we get 2 is equal to 0. And so finally this becomes c squared by 2 multiplied with, what is 16 minus 12? It is 4. Plus c multiplied with minus 3 plus 2 is minus 1 is equal to 0. And so from this we get, so this 2 and this 4 gets cancelled twice. So 2c squared and plus into minus is minus c is equal to 0. We observe that c is common in this term, so we can take it out, and so we get 2c minus 1 is equal to 0. So we get one of the value of c to be equal to 0 and the other value is 2c minus 1 is equal to 0. So what will happen? From this we get 2c to be equal to 1, and so therefore the value of c is equal to 1 by 2. So one of the value of c is 0 and the other value of c is 1 by 2. Now we shall write the equation of the asymptote. So when m is equal to 1 by 2 and when c is 0, so what will be the equation of the asymptote? A second asymptote is y is equals to m2 x plus c2, which is equal. So from this we get y to be equal to m2. m2 is what? 1 by 2. So 1 by 2 x plus c2. But what is c over here? It is 0. So anyway that will be not there. So from this we get, taking this 2 to the left, it will become 2y is equal to x. And so therefore we get 2y minus x is equal to 0 is the second asymptote. And to find the third asymptote, we have to take the other value of c. But anyway the value of m is same only. So m3 is equal to 1 by 2 and c3 is equal to the third value of c, which is 1 by 2. So let us write that. So 1 by 2. And so the equation y will be equal to m3x plus c3. So therefore from this what do we get? Y to be equal to m3 is what? 1 by 2. So 1 by 2 x plus c3 is 1 by 2. So 1 by 2. We observe that the LCM on the right is 2 and after taking LCM we can multiply it with y on the left. So this equation will become 2y is equal to x plus 1. Bringing all the terms to the left hand side, we get the third equation of the asymptote to be 2y minus x minus 1 is equal to 0. So this is the third equation of the asymptote. So we have found all the three equations of the asymptote, where the first equation of the asymptote was y minus x is equal to 0. And the second equation of the asymptote is 2y minus x is equal to 0. And the third equation is 2y minus x minus 1 is equal to 0. So we have found all the three asymptotes of the given equation, which are oblique. So I hope you have understood this problem completely. Thank you.